What's up, people? If you were here Friday, we went through this activity where you're going to answer the following two questions: how much force do springs apply, or how much force does a spring apply, and how much force is required to stretch or compress. I really should probably say your spring, the one you used, 1 meter. All right. Some things to think about that are on the lab. Again, well, never mind. Um, it actually isn't very clear on the lab, but you should plot things that way. All right, and make sure that you're aware of what X refers to. Okay, and X, I will say, always measured relative to what's called that natural length or original length. So you don't compare. Well, first, we stretched it this much, and then we stretched it this much, and then we stretched it this much, and then this much. Each of these is not a delta X or an X. X is from here, and then from here, and then from here, and then from here. Always from the original length, or what we call the natural length. Okay, so make sure you're okay with that. What else? The other thing is, how much force does a spring apply? Now, what you likely did was apply some force to the spring, and maybe even measure the amount of force that you were applying to the spring. But that's not the question. The question is, how much force does a spring apply? So in some way, you're going to show me a very simple little analysis via a free body diagram that shows how you are actually figuring out how much force the spring applied. Okay? Not how much force you applied to it. Or an object applied to it. Let's see, what else? You're going to make this graph. Of course, I'm not going to show you what the graph looks like, but it should be a very clear pattern if you were at all careful with your data collection. What else? Yeah, I mean, as we said in the handout, your answer should start with the phrase, or in some way should include the phrase, that depends. The amount of force that a spring applies depends, right? And look at, let's see, if I have a copy of that. I do, here I do. A copy of the lab. Let's see, yeah, when we look at, in the middle of the page where it says how much force the springs apply, right, we talked about number one, where you're talking about the force that the spring applies. Yep, you definitely got to touch on number two. Does the spring always apply the same force? And the second part of number two, do all springs apply the same forces? All right, so make sure that you can not only talk about what your spring did, but maybe you can sort of say, well, we've physically looked at different springs, and here's how they might behave differently. All right. And why they might behave differently. Okay, so I think that's about all. Yeah, when you come in Monday, you'll have a graph. You'll have some answers to questions. You'll have you'll have a free body diagram with some sort of net force statement that shows some sort of simple calculation. You'll have a data table, and you'll have answers to these questions. All right, and I will tell you also that this question, in some classes, we talked about extrapolating and maybe using Excel to forecast out all the way to 1 meter. You don't have to do that. All right, you can make a good graph that fits your data, on the range and domain or whatever you call it of the axes, and with that graph, there's a way to figure out the answer to that question: how much force is required to stretch, in this case, stretch your spring 1 meter. And I will say, maybe you ask yourself, what units might some number like this have? I mean, really, how much force? It's going to be a number of newtons, right? But when you say how much force to compress it, or sorry, how much force to stretch it a meter, think of how there might be some quantity that talks about that, or that quantifies that, and how might you find that from your graph? All right, remember, we make graphs for a couple of reasons. One, to identify trends in data, and two, typically to find something else interesting about a system or a scenario that's not necessarily the quantities that are just written on the axes. All right, so think about the typical processes we go through when we do some analysis with graphs, and what you might be able to find by doing some of those typical analyses. Okay, so a little bit, what's the word? A little bit vague in my instruction, I understand that, but should be no surprise, I guess. Happy weekend, people. See you on Monday. And for Block 3, folks, you will have your conservation of mechanical energy quiz, but nothing about springs on that quiz. Okay, adios.